Hello students, in this video we'll see an example of finding the conditional expected value of a random variable given another random variable as a fixed value. Let's consider jointly distributed random variables x and y with joint PDF proportional f of xy is proportional to x on the region x goes between 0 and 1 and y goes between x squared and x. Let's find the expected value of x given that the random variable y is equal to little y. So as we do with these problems, the first step is to sketch the region of integration. So the support of the joint PDF, here's the x-axis, here's the y-axis, and x goes between 0 and 1, and y goes between x squared. So this is the graph of x squared, this parabola. That's 1. And then y equals x is above the parabola between 0 and 1. So this is my parabola, y equals x squared, and this is y equals x over here, and this is my domain of integration, this shape over here. So to find the expected value of x given that y is equal to y, what we need is we need the conditional density function. So we need, in this problem, f(x) that y equals y of x given y. And what this will be is this is equal to the joint PDF over the marginal f(y) y. So let's find this marginal distribution. So my marginal distribution, f(y) is going to be the integral of the joint PDF, c times x, with respect to x. We need to figure out where x goes in this region. Well, we can see that x goes from y over to the square root of y. So x goes from y to the square root of y in this region. And so now we can compute this. So fyy is going to be equal to c x squared over 2 evaluated from root y to y. So this will be c over 2 times root y squared is going to be a y, and then minus y squared. So that is our marginal. So that tells us that our conditional PDF, so our conditional PDF, f(x) y equals y x given y, is going to be c times x, the joint PDF, divided by c over 2, and then y minus y squared. So the c will cancel out, and the 2 can go on top. So this is going to be 2x over y minus y squared. So now we have our conditional density function, and that tells me that the expected value of x, given that y is equal to y, is going to be the integral. I have to integrate over the x region of integration, so I have a dx over here. And where does x go in this region? X goes from this region, as we saw before, from y to the square root of y. And then I do x times the joint PDF. So I'll have a 2x over y minus y squared. And so we can pull that y minus y squared out of my integral. So this is going to be 1 over y minus y squared. And then what's left of my integral is 2x squared, and that's going to integrate to 2/3 x cubed from root y down to y. And so the top will be what? The top is going to be 2/3. And then we're going to have a y to the 3/2 power minus y cubed from the limits of integration divided by y minus y squared. And we can simplify this a little bit. 2/3. I can pull a factor of y out of the top and the bottom. If I do so, I'll be left with root y minus y squared on top. If I pull a factor of y at the bottom, I'm left with 1 minus y. And 2/3 root y minus y squared, all divided by 1 minus y, is the expected value of x given that y is equal to y. Thank you very much.